7.6, solve systems of linear inequalities. So, a couple weeks ago, after all the snow, or well, before all the snow, I guess, we were graphing inequalities. I don't even know when that was. Anyways, it was a while ago, where we were doing the solid or dotted and shading it and all of that. So, but that was just one line, right? Like we were just doing one at a time. So these ones could be 2 lines, 3 lines, 4 lines, whatever, and we're going to be shading. And wherever, because there's going to be, typically what we're going to be doing is 2, wherever both areas are shaded, like wherever, how do I explain this? Whatever has like the 2 different colors of shading is where the solution is to the system. So you may want like some highlighters that are different colors to do your shading with for this. You can use a pencil, but it's a little bit easier to see with like some highlighters and stuff like that. So anyways, totally up to you how you want to do it, but as we go through examples, I'll be using different colors of like highlighters to shade this stuff. So, first things first, a system of linear inequalities, if I can spell, is are 2 or more, or consists of 2 or more inequalities in the same variables. So, for example, I could have 2x plus y is greater than 3, or I could have y is less than or equal to, yeah, I actually can do that. Doesn't even have to have an x in it. So they don't have to both be like less than, both greater than. It can be, one of them can be or equal to. They don't have to both have an x and a y. It can just be a y equals, quote unquote, or x equals. And even though they're inequalities, they would get graphed the same way as if it was like a y, just y equals whatever, or x equals whatever. It's just if it's just less than or just greater than, it's obviously just a dotted line instead. So, as far as graphing the system, of linear inequalities, step 1, graph each inequality and I would use like 2 different colors. So like I would use like a yellow highlighter and a pink highlighter or something like that, so you can see, you know, clearly what's what. Just as a refresher on this, if it's just less than or just greater than, it's dotted. If it's less than or equal to or greater than or equal to, it is solid. And then step 2, find the intersection of the, they call them half planes, which I feel like that's a really weird word, but it just basically means the areas that are both shaded like at the same time, which that'll make more sense once we actually do some. And technically the graph of the system is that intersection there. and I don't know if our book will do it, but I know in the Algebra 2 book it happens sometimes. It is possible that you may have two inequalities that you graph that they don't shade in the same direction at all, where there's no overlap, and in that case it's just a no solution. But I don't know if our book does that or not. We'll see as we go through some examples. And just like when we did the problems, if you remember when we like shaded an area and I said you can take that point and you can plug it into your equation and you can see like, is this a solution or not? You can still take a point in the area, the region that's shaded by both, and that point will work in both equations, and that way you'll know if you shaded it correctly. So we'll do that on a couple, but probably not all of them, just for the sake of practice for today. All right, so let's see, graphing the inequalities here. Number 10, I've got y is less than or equal to 10, and y is greater than or equal to 6. So I'm going to count by twos, just so that my graph's not so big. Remember, if you're counting by something other than just ones, you do need to put labels on it. So what would a graph of just like y equals 10, ignore the less than or equal to, greater than or equal to, what would that look like right now?
A solid line going horizontally at 10.
Yep, a solid line. So I like to also, if I'm going to be like shading or whatever in different colors, I like to put a little marker beside what each one is, just so that if I go back I can tell. So in this case, this is just a straight line going across here. And it's solid because it's or equal to. I know you're not going to help me graph that. Okay. So y is less than, so which direction do I shade?
Below.
Yep, so I'm going to use a lighter blue just so it's not so. So that means everything down in here is getting shaded. So then what about, I'm going to use red for the other one. So what would the y greater than or equal to 6 look like?
Horizontal line at 6.
Yep, horizontal line at 6. And which direction does this one shade?
Up.
This one shades up. I'm going to use pink to shade it. So that means this one shades up in here. So what do you notice happened with me using the highlighters to shade?
They combined.
They combined. So the area where the colors blended, and that's why I used like pink and blue. So it would make this purpley color. My solution to the system is this region that's shaded by both colors. So if I picked any point in here, so let's say I chose y equals 7. 7 is greater than or equal to 6. 7 is less than or equal to 10. So I know I've shaded in the right direction. Okay, now it's obviously a little dramatic with this one. With ones that are lines crisscrossing and going every which way, obviously it makes it a little easier, or it's better to check them on that one. I don't really need to check this one, but does that make sense? So that's why I like the highlighters, because that way wherever the colors have blended, you'll know that's where your solution is. Okay? Let's see. 12. Y is less than negative 2x plus 3, and y is greater than or equal to 4. You ready? Is there anybody in the lab?
It's just Bella.
Okay.
Can I plug my iPad in also? Plug.
You can just plug it over here if you want.
Okay.
And I'll just set that right there for you. You can grab it.
Thank you.
Do you know if Chris is coming?
He said he's gonna study a little more.
Okay, that's fine. I was just wondering. Where did I just pencil over here? Okay, so what do I do with the top graph? What do I know about it?
It's gonna be diagonal.
Okay, what else? It's diagonal. What does the just less than tell me? It's going to be dotted. What else? What do I know about my shading? It's going to shade below. All right, so what is my y-intercept of that one?
-2. No, wait, no, 3.
3. 1, 2, 3. And what's my slope?
-2.
So what does that tell me I need to do? Down 2, right 1. Down 2, right 1. And I don't have to keep going. That's sufficient. So it's a dotted line. So that means I'm just going to do my best here. And remember, if you're using your colors to do this and not just graphing your lines in pencil, and just using your highlighters to shade, if you ever accidentally do solid and you know it's supposed to be dotted, okay, then you can just make a note and say this should be dotted, okay? You don't have to go back and try to go find white out and whatever. Just make a note that you did it wrong. Now, if you do it dotted and it's supposed to be solid, please connect the dots. Makes sense. All right, so I'm shading below, so that means I'm shading down here. I'm going to get my blue. So it's shaded where y is smaller, so that means it's down here. It's this whole area in here. Now, what do I know about the other line?
Horizontal.
It's solid.
It's solid and above.
Yep, solid and above. So at 4, 1, 2, 3, 4, it's a horizontal line going across. And I shade above. Let me go get my pink here. So you shade the whole line. Don't just shade the area where the overlap is. Does that make sense? Some people just shade this little tiny chunk over here. I'm like, no, you shade the whole thing just like you normally would. Now, obviously, I could have kept shading up on my blue area here, but I had stopped because I didn't know how much higher I was going to need to go. So this whole area up in here would be my solution. Okay, and obviously if I extended the graph and made it bigger, it would keep going up. It would keep going to the left. It'd be that whole region. But just what I can see on my graph, it's this region here that's overlapped. So choosing colors that mix well, like blue and yellow, making green, whatever. Good things to do. Makes it easier. Unless you're colorblind, then just look for where it gets darker, I guess.
I'm not colorblind.
Are any of you colorblind? I'm just curious.
No, I'm not.
No?
This one could
Okay.
I'm like, over you and Sam.
Maybe.
Actually, yeah, maybe.
No, one of my friends is colorblind, and I always feel so bad. Yeah. I always feel so bad
Hey,
for
look at
them.
this red sandwich. What?
Wait, why is your sandwich red? You add food coloring to the bread?
In America, we're not gonna do that.
Yeah, Americans have red sandwiches.
Yeah.
with it.
I want to see.
Where you come from?
Yeah, we from the U.S., dude.
All right, y is greater than or equal to 2x plus 1, and y is less than negative x plus 4. All right, so what do I know about the top one?
It's solid and right above.
Solid and above. What do I know about the bottom one?
Dotted and below.
Yep, dotted in below. So I'm just going to go ahead and note that stuff so that I have that taken care of. I'm going to set up my graph over here. All right, so the top one, what's my intercept?
1,
And what's my slope?
2.
So up 2, right 1. Or I can go down 2, back 1, just as a refresher. So this one was solid, so I'm just going to connect here. So I shade above. So that means up here, if you're ever not sure on that one individual graph, if you shaded correctly, you can always choose a point like we did before, and you can check it. So I'm going to shade this area. And obviously, it's not necessarily going to be perfect. All right. Over here, what's the intercept on this one?
4.
4. So 1, 2, 3, 4. And my slope,
Negative 1.
what does that mean?
Down 1. Down 1, right 1.
Down 1, right 1. Or I can also do up 1, back 1. And this one's dotted, so I'm going to make sure I pay attention to that. That's why I have to write it first so that I don't end up doing the wrong thing, because that's just super annoying. And this one is shaded below, so I'm going to go back to my pink here and shade below. So this area over here is my solution. All right, so I haven't checked one yet, so let's choose this one. Let's choose a point here to check. So what's a point in this region that I could check?
Negative 1, negative 1, 1.
Negative 1, 1. So this is how I'm going to check it. And you got to put it in both equations. You can't just put it in one because it might work for one and not the other, depending on if you've done stuff correctly or not. So I'm going to do the top one first. So 1 is greater than or equal to 2 times negative 1 plus 1. So 1 is greater than or equal to negative 2 plus 1. 1 is greater than or equal to negative 1. Is that true?
Yes.
All right, so I'm good on that one. So I'm going to check the other one now. Same point. Plugging it in here. So I've got 1 is less than negative times negative 1 plus 4. So 1 is less than 1 plus 4. 1 is less than 5. Is that true?
Oh, yeah.
Yep, so I know that I've shaded correctly and I found the solution point. Make sense?
Yes.
Cool. All right, so obviously these ones so far have been nice. They've had y by themselves, either completely where there's just like a number, or it was already in slope-intercept form. Sometimes they aren't that nice though, and they don't give it to us in that form. So I've got y is greater than or equal to negative 2, and 2x plus 3y is greater than negative 6. So a couple things. One, I can get y by itself. Does anybody else remember how I can graph this without having to move things around?
No.
Just like make the 2 a negative and treat it as like it's m. Trust me, bro.
You can't.
Wait, no.
I don't trust him.
Wait, trust is negative 3 over 2x.
What about standard form? How did we graph in standard form?
Oh.
Y
standard form
one
again?
Y1 minus
Y2
Y2 equals
That's point
X.
slope form.
It's the ABC.
No, Y1 equals X parentheses
Oh,
X.
ax plus by equals c.
So how did I graph though? What did I call that method?
Oh, the cover up.
What am I doing? Cover up method. Okay. So I could graph by that method because on these ones it doesn't matter. Okay. In 7.1, when you're solving by graphing, a lot of times that doesn't work because it doesn't extend your line far enough. Okay. On this one, I'm going to do that one as well. I'm going to solve for y so you can see that, but then I'll also graph by the cover up method so you can see how it works on this one. Because I feel like we need some practice on getting y by itself. So to get y by itself, we subtract 2x. So 3y is greater than negative 2x minus 6. The other thing to note, what happens when I multiply or divide by a negative? It's not true of this problem. I'm just asking in general.
Wait, what was it?
If I multiply or divide by a negative in an inequality, what happens? It flips the inequality. So sometimes that happens when you graph them. Okay, this one is not that way because this is a positive 3, but just know that sometimes that happens. So divide by 3, so y is greater than or equal to negative 2/3 x minus 2. So this will be the line that I'm working with. So what do I know about this one?
Fraction.
It's solid.
Negative fraction.
What else?
Oh, below.
Greater than.
Above.
Above.
So it's solid and above. What do I know about this top one?
It's
Above is
solid
Above
and
and
above.
solid and above.
I'm gonna see if y'all can catch a
Wait
mistake.
a second.
No.
Hang
Cookie
on.
point.
Why does that one not have
No,
a
she
line
knows
but
the
that
mistake.
one does?
So it's not solid, it's dotted.
She got it, yeah.
Yeah. How did we get the line?
Because I wrote the wrong thing and I was seeing if y'all were gonna catch it.
No.
Are we
So what should
sure?
this actually be?
Dotted.
Should be
Dotted.
dotted.
No, she got it.
Huh?
Wait,
She wrote it on purpose.
No, I did it on purpose to see if y'all would catch my mistake.
We did.
Hey.
What do you mean we?
I did. Yeah, guys.
I did.
Yeah, I did.
I don't know.
Everybody gets cookies. It doesn't matter. Are you ready?
Hey, Chris.
You can start it during sevens. You don't have to start it.
I know I'm not, like, I've been looking at it all day and there's no way it's gonna stick anymore. I'm
There's
screwed.
only
I'm
four
like,
multiple
oh.
choice questions if that makes you feel any
That
better.
doesn't agree with it. That means it's mostly terms.
Why do you have
Flip the
guys
pages.
worshiping
Pages.
your
Are they front and back?
Yeah.
Oh.
You're gonna have to put that away before you
Yeah,
get
can
this
you,
though.
do you want to trade off? And
Yeah,
come back and
sure.
get it?
Oh, wait, we are on.
You're right there.
Alright, wait, are you taking it?
Almost tough.
What do you want
She's
to
in
do?
the computer lab. You can just start in there. Once the bell rings, you can come in here, but we're still working in here, so.
I know.
Some of the mangoes.
Are you hearing?
Bro, I saw it.
Oh, you're married to
I saw it.
I know because I'm sitting in my
That's
face,
gonna
but it's
do
not
this.
sticking. I hate it. I hate when that happens.
I'm not very
Yeah, I think it's a little Beagles. I think it's a little Beagles.
Alright, if I use the cover up method, I'm still gonna have to work it down to here so that I know which direction I'm shading. Okay, the cover up method here would say that I have an x-intercept at what?
-3.
-3. So that means right here I have a point. What about y? -2. I'm about to put it at +2 and y'all about to get another cookie point. So if I did it with the way that I got y by itself, my intercept's at -2. I have a slope of -2/3, which would tell me to go down 2, right 3, or up 2, back 3. So it's in the exact same spot, so it doesn't matter. So this one was, before I do it wrong again, dotted. Oh gosh. This is a very crooked line. Don't judge my line, guys. It's very crooked.
Oh.
I'm judging, guys. I'm judging.
No, this is a cookie, you can't judge.
I also just did the colors back. Yeah, I don't care. I'm just gonna do this. This one's blue and this one's gonna be red.
Oh.
It's fine.
That's not what you were talking about.
I'm just struggling on this problem apparently. Alright, it's shaded above, so that means it's getting shaded up here. What does this other line look like?
Solid at
Solid
-2.
and above.
It's solid at -2 and it's a straight parallel. Well, not parallel. Horizontal. You're out of shape.
And I shade above,
Yes.
so that means
Stop laughing like that.
up here it's shaded, so this overlapping area here is my solution.
Looks like chaos.
This is probably the most chaotic you get to be in math.
Yo.
You know, this is changing my opinion about graphing.
You only
I
like it
have
because
2
you're colored.
highlighters and a red pen in my hand.
Must have 2 highlighters, 2 pieces of paper.
Chris, you only like it because you're
Alright, 18.
You're telling me, Buster?
X is less than 4. Y is greater than 1. And y is greater than or equal to -x plus 1. What's
What?
different about this problem?
Oh my god.
There's 3 of them. What else?
Yeah, I'm chopped.
I don't know actually. There's 2 Y's.
Wait,
X is greater than 4.
X is greater than 4, what?
X is less than 4.
Why are you-
Says X is less than 4. We haven't had one that was X yet. We've only had Y, or like an actual equation of a line. So I'm gonna have to do 3 colors this time. I'm gonna go ahead and set up my graph.
I don't have that many colors. Bust out a yellow one.
Grace.
Wait,
I got 2 things.
Grace,
Can't
you
wait
got-
till I get like 6.
do purple and orange.
Can't wait till we get to 6.
No. Purple or
I got it.
ugly combination.
Do what with your pink Sharpie?
Well, per the request, I guess we're going with purple.
You guys are weak, bro.
All right, so x is less than 4. What is that graph gonna look like? What is this x is less than 4 gonna look like?
It's gonna be dotted. And X is going to be left.
Okay, so that means it's gonna be shaded to the left, okay, because it's x. So I have at 4 a vertical line going up and down. And it's shaded to the left. So that means it's over here. All right. What about the y is greater than 1?
Wait, isn't it supposed to be a dotted line?
Look at that.
Cookie boy.
No,
we're cooking.
No.
Wait, we're in first place.
Before I do anything,
Oh, yeah, we're tied.
We're tied.
Calculus is gonna be mad.
No, Unc is not that kind.
I'll just start over apparently.
Wait, where's Unc?
Unc, he
Wait.
doesn't do math. He's too
Wait,
tough on
why
that.
why does calculus, do they want to be in first place?
Everybody wants to
Everybody wants to be in first place.
They just question how I can make that many mistakes in Algebra 1, I think, is what that really boils down to.
Yeah, you definitely do it on purpose, right?
Mhm, totally.
It's all on purpose.
Oh, yeah, for sure.
Yeah.
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 Alright.
The math teacher.
Glad y'all think so.
I may have realized.
The math teacher.
All right.
It's gonna be horizontal, right?
Yep. At 1.
We got like
All right, which direction do I shade this one?
Left. Right.
Up. It's Y.
Ow.
At this point, you're just good.
Wait, it's orange. She's doing orange.
Oh.
Yay, brown.
Why did you
That's
suggest?
not brown, that's red.
Because it looks
Color-
all.
I don't even know, bro.
Yeah.
Tom,
Oh,
we do
have
a colorblind person.
Wait, I thought purple.
You already done.
Oh no!
Nice.
Add it.
More scared for tomorrow.
Oh God! Help, Grace. Look at Grace's paper. Grace show Jonathan.
All right. All right, what about this one?
B equals
solid.
1,
Solid.
M equals -1.
Solid.
It's solid and it's shade which direction?
Up. Upright.
So my slope is negative, so down 1, right 1, or up 1, back 1.
Oh, I can't even see my paper anymore. Probably because you were using an expo marker that bled through.
Oh my!
I need 3 colors.
Oh, I have 3 colors.
All right, so this one, look, it shades up here.
Oh, now it's brown.
So look, this area where all the colors are is my solution. Okay, we're gonna do like 2 more tomorrow, and then I'm gonna give you the rest of the time to work tomorrow, so you'll have a work day tomorrow.
Alright, guys.